All right, so I made a video since I'm not in class today to go along with the notes and examples I posted in case you are having trouble understanding what to do with polynomial inequalities. So these are just the steps, and then we'll go through those examples. I'll explain to you what you're seeing in regards to the steps. So when you're solving, you would want it equal to 0. So that would be your first step, is to make it equal to 0. Get it factored completely so that you can sketch the polynomial. So all of this, setting it equal to 0 and factoring, is all for the purposes of sketching. So then once you have it factored, you can get the x-intercepts, you can get whether it crosses, its tangent, or an inflection, the end behavior, and you make a sketch. So then based on your sketch, you're going to make a sign chart. A sign chart is just a number line where the important points on the number line are your x-intercepts from your sketch. So then you're going to look at your sketch, and if the section on the number line is on the sketch above the x-axis, you're going to put a plus sign. If on the sketch the section is below the x-axis, you're going to put a minus sign. The plus sign sections would work for greater than or equal to, and the negative sections that you wrote on your sign chart would work for less than or equal to. Points of tangency are going to be special. That's really the only time that on your sign chart you wouldn't alternate between positive and negative sections. And it'll be important depending on whether you have the or equal to on your inequality or not. Then finally, you should state your solution in interval notation, just like you should know anyway. If you have or equal to with your less than or greater than, you would use brackets for your interval notation, and if not, you would use parentheses. Okay, so your first example, let's see if I can get this moved over somewhere. I can't get this moved over. Okay, never mind. All right, so first example, 9x squared minus 6x plus 7 less than or equal to 15. So first step is to set it to 0. So I move the 15 over, and 7 minus 15 is negative 8. Then you get it factored, and this is one that's a trinomial with a leading coefficient. So if you're doing it the long way, you'd need to find two numbers that multiplied to give you negative 72 and added to give you negative 6, and you would come up with those numbers as negative 12 and positive 6. You would replace the negative 6x with the negative 12x plus 6x, and then factor by grouping, and you should end up with the factored form of 3x minus 4 times 3x plus 2, still less than or equal to 0. So based on when you set it to 0, you could tell that it's even and positive, or from this point, two x's, they're both positive, even and positive, so the end behavior is up on both ends. The x-intercepts are 4/3, and it's across, and this is negative 2/3, also across. So it's a basic parabola that turns down with an x-intercept at negative 2/3 and one at 4/3. So I do my sketch. You can see where I did the plus and minuses. This section of the graph is above the x-axis, so that would be a positive section. This section of the graph is below the x-axis, so that's a negative section. And this section of the graph is above the x-axis, so it's a positive section. So here's my sign chart. The only points I need to label on my number line are the x-intercepts. So then the same way I described the positive and negative sections, this represents a section that is to the left of negative 2/3. So here's negative 2/3, and the graph that's to the left of negative 2/3 is all above the x-axis, so that gets a plus. The section of the graph between the x-intercepts is below the x-axis, so that's negative. And the section of the graph that's to the right of 4/3 is all above the x-axis, so that's positive. If you go back up here and look at when you set it to 0, your inequality was less than or equal to 0. Less than or equal to indicates that you want the negative sections, including the x-intercepts. So I just want this section of the sign chart because that's the only negative section. And again, it's negative because of less than or equal to. I would use the positive sections if it had said greater than or greater than or equal to. So I would use brackets because of the word equal to, and it's just this section, so it's between negative 2/3 and 4/3. Okay, so less than or equal to 0 means you want your negative sections, including the x-intercepts. Let's go to the next example. Okay, so this is already set to 0, so we can just go ahead and work on getting it factored so that we can sketch it. There's 4 terms, so that's going to be factored by grouping. So I factored out the GCF of each group, and my common binomial was x minus 3. The other stuff was x squared minus 4, and x squared minus 4 is difference of squares, so I could continue to factor that. So this is completely factored. I have 3 x-intercepts. 3 is across, negative 2 is across, and 2 is across. The end behavior is odd positive, so down on the left and up on the right. So I make a sketch based on the end behavior, the x-intercepts, and that they're all crosses. So here's my sketch. Again, I wrote the positive and negatives here just so you could see how it related to the sign chart. This section of the graph is below the x-axis, so that's a negative section. This section of the graph is above the x-axis, so that's a positive section. This is below the x-axis, so it's a negative section, and this is above the x-axis, so it's a positive section. So on my sign chart, I just labeled the x-intercepts. There were 3 of them. So the same thing I did over here with the positive and negatives. On the graph to the left of negative 2, that part of the graph was below the x-axis, so that's a negative section. Then between negative 2 and positive 2 is above the x-axis, so that's a positive section. Between 2 and 3 is below the x-axis, so that's a negative section. And to the right of 3 is above the x-axis, so that's a positive section. So then, because the inequality was greater than 0, that means I want positive sections. Greater than means positive sections. There were 2 positive sections on my sign chart, here and here. So I'm going to have 2 parts to my solution. It was just greater than 0, so it does not include the endpoint, so you need parentheses. So this section is between negative 2 and 2, and this section is 3 to infinity. Again, with parentheses because it was just greater than 0, so it does not including x-intercepts. All right, I have one more example. All right, this has already been factored. It's already set to 0. It's already been factored, so you should be ready to sketch. It's a way more complicated one with all the x-intercepts, so that's why it's already factored for you. So we have 4 x-intercepts, 0, -1, 3, and -4. Even exponent makes it tangent at 0. It crosses at -1. Odd exponent makes it an inflection at 3. And cross at -4. There's 1, 2, 3, 4, 5, 6, 7 x's, so it's odd. And all the x's are positive with this negative sitting on the front, so the whole thing's odd and negative, so it goes up on the left, down on the right. And so you're able to do your sketch. It crosses at -4, crosses at -1. It's tangent at the origin and an inflection at 3. So when you come over here to your sign chart, you're just labeling the x-intercepts. The part of the graph to the left of -4 is above the x-axis, so that's a positive section. The part of the graph between -4 and -1 is below the x-axis, so that's a negative section. Pay attention to tangents because it could stay all above the x-axis or it could all be below the x-axis depending on the sketch. So from -1 to 0 is above the x-axis, and between 1 and 3 is above the x-axis because of it being tangent. That's the only time that you should repeat a positive with a positive or a negative with a negative when you have tangents. And then the last section is to the right of 3, and that's all below the x-axis. That's negative. The inequality was greater than or equal to. So that means we want the positive sections, including the x-intercepts. So I have a positive section here, and then this is a double positive section. So there's going to be 2 intervals. -infinity to -4, use a bracket because you have or equal to, so it includes x-intercepts, and -1 to 3. So then the question is, if x was greater than 0 instead of x is greater than or equal to 0, what would the answer be? So if it were just greater than 0, then that means you could no longer include the x-intercepts, which means you couldn't do one big section right here, because this section, -1 to 3, includes the x-intercept of 0. But if it's greater than 0, we're not allowed to include the x-intercept of 0. So we would have to change our answer so that we'd still have -3 to -4. We would change the bracket to a parentheses, but instead of this being one big section, we'd have to change it to 2 sections so that 0 wasn't part of our solutions. All right, that's it. Hopefully that makes sense. You do need to do the sketch and the sign chart. I know you might feel like, well, I got it from the sketch. I don't need to do the sign chart, but the sign chart will come up in calculus. So you're going to need to know how to do a sign chart. So just get in your practice now. Okay, hope that was helpful.